Today we are going to look at ternary nomenclature, where we're looking at the combination of polyatomics with other metals, or we're looking at a combination of multiple polyatomics. The nomenclature is exactly as we do ionic nomenclature for binary compounds, where we have to consider the charge of the metal. If the metal is univalent, we name what we see. If the metal is multivalent, and what do I mean by valent? Number of more than one charge. Multivalent is more than one charge. We need to use the Roman numerals. So I am just going to go through, since you're at home watching this, I can't be very interactive, so I'm literally just going to read through the names of these compounds. NH4NO3 is ammonium nitrate. KNO2 is potassium nitrite because of the 2 on the polyatomic. Here we have a funny polyatomic called perchlorate. So this is calcium perchlorate. Notice up to this point I haven't used any Roman numerals because all these metals are univalent. But here we get to one that has multiple possibilities. Copper can be 1 or 2. Because because carbonate is a -2, this copper has to be a +2. When you do your UT homework, you might run into some of those old-fashioned names, those Latin root names, and I just want to go over really quickly how to recognize them. If you remember, ic is high, us is low. That will help you remember that if the funny Latin name ends with an ic, it is the higher of the 2 charges that we're describing. If the funny name ends in an us, it's the lower of the 2. So for instance, copper 2 is the higher of the 2 possible copper charges, so we call it cupric carbonate. The word cupric replaces copper 2. If we decided it was copper 1, it would be cuprous. So if you see things like nickelus, nickelic, you can figure out that's nickel with its 2 charges. Ferrous, ferric is iron. Cobaltus, cobaltic is cobalt. Stannous, stannic is tin. Plumbus, plumbic is lead, and so on. So I think knowing this ic is high, us is low will be sufficient for you to finish any UT homework that you need to complete. Just know that you're not going to be tested or quizzed specifically in class on that. All right, next, this is sodium cyanide. Cyanide is a Cn-1 polyatomic. It's one of 2 polyatomics that do not have an ite or an ate ending. I can't spell. Cyanide. Next is barium sulfate. This one, we got to be careful because mercury can have more than 1 charge. So it's mercury 1 oxide. This guy is a little different. Don't let the little h scare you. That h, you may either call it hydrogen, just actually say what it is, or use the prefix bi. What that does, you chunk it in front of the polyatomic and it will actually drop the polyatomic charge by 1 because it itself is a positive 1. So this right here, you guys actually know what this is probably. It is sodium bicarbonate or sodium hydrogen carbonate. Both are totally acceptable, and that is baking soda. All right, that's our last one on that page. Let's go ahead, and now we're going to go the opposite direction with these, and we're going to write the formulas. Lithium is +1, carbonate is -2, so we get Li2CO3. Magnesium is +2, hydroxide is -1, MgOH2. Don't forget those parentheses. If you don't have the parentheses, it's wrong. And do not use parentheses with only one polyatomic. Only use them with multiples. Lead 2 permanganate. So we know permanganate is MnO4-. So this would be PbMnO4 2. Chromium 3 chloride. Chloride is -1. The chromium is 3 based on the Roman numeral. And so that's that. Zinc is +2 and nitrate is NO3 -1. So we need 2 of those nitrates. Strontium sulfate, both of those are going to be + and -2. So there we go. Here's with our cyanide. Again, one of the few that actually have an IDE ending. It's a -1, so we need 3 of them because of iron's charge. Acetate is a popular polyatomic with a -1 charge, C2H3O2, to balance out lithium's positive charge. Okay, mixed problems. Again, I'm just going to start reading and writing for you guys. So the first one is ionic with a polyatomic, so it's sodium sulfate. We have absolutely no Roman numeral there. Oh, SCl2. Hopefully the bells went off in your head that this is a covalent compound, so it's sulfur dichloride. Use your prefixes. Potassium permanganate. Oh, I'm going into the other column. And then here we have manganese with oxygen. A lot of people want to say manganese dioxide. That's not the case because it is ionic. So this is manganese. There's 2 oxygens, each at a -2, so that makes manganese 4 oxide. Next up, chromium 6 nitrate. So chromium has a +6 and it's nitrite. That would be a 2, and then we need 6 of them. Sulfur dioxide, that should be an easy one for you. SO2. Ammonium iodide. Ammonium is a +1. I is a -1. Copper 2 phosphide. Remember, IDE comes from the periodic table. It is not a polyatomic. So Cu3P2. Next is magnesium sulfate. Chromium. What kind of chromium? Based on the charge of the phosphate, it has to be 3. Next up is our cobalt in combination with our carbonate. And it looks like it's hard for me to see, but I'm going to say that's a 3, and I'm going to say that's a 2. So it is cobalt. Oh, it can't be, because that would make the charge wrong. So I'm going to say, let's start that one over again. I'm going to say that is a 2, and this is a 3. So cobalt 3 carbonate. Sometimes the resolution makes these numbers tough. And then this one is a covalent, and it is sulfur trioxide. So I can continue down the page. Nickel 2 hydroxide's formula is NiOH2. And then we've got sodium peroxide. I don't think that's on your polyatomic list, but it's something you need to add. O2 -2. That is a polyatomic. You've heard of hydrogen peroxide. That's H2O2. So that'll help you remember it. So it's Na2O2. Osmium 8 oxide. Osmium is OS, O4. And then gold 3 chloride, AuCl3. Now we can move on to acid nomenclature. There are 2 kinds of acid types that we need to be able to name, and those are binary acids and ternary acids. How do we know something's an acid? You probably have an H in front of it. And then binary means it only has two types of elements in it. If it is binary, we call it hydro something ic acid, like hydrochloric, hydrofluoric, hydroiodic. For instance, H3P, that's only two types of elements, so we call that hydrophosphoric acid. Be careful with sulfur and phosphorus. When you change the ending, you have to add another sound. So it's not sulfic acid, it's sulfuric acid. It's not phosphic acid, it's phosphoric acid. So you have to add another syllable. Ternary acids have polyatomics in them. If your polyatomic ends in ite, you get an acid that's something us acid. If it ends in ate, you get something that's something ic acid. You might have heard in Chem 1 some of your teachers have sayings. They say it different ways. I say ic. I ate a humongous bite. So you know that if the polyatomic ends in ate, it goes with the ic acid. If the polyatomic ends in ite, it's an us ending acid. So we're just going to go name. Starting with the top one, the first obvious thing you're like, why does one say gas and aqueous? They're the same thing. If someone went to the trouble of actually putting a G next to the acid, what they're trying to tell you is it's in gaseous form, and we name it just like we would any other ionic compound. So we call that hydrogen chloride. But it's two nonmetals. Why do we say it's ionic? Because in actuality, that is a transfer of electrons, and it will actually dissolve in solution. So we treat it like an ionic compound. Here, HCl, because it's in solution, we can treat it like an acid. So it is a binary acid, so we call it hydrochloric acid. HClO4 is that funny polyatomic. It's perchlorate, so we call it perchloric acid. H2CO3 is also a ternary acid based on that, so we call it, it's an ate ending, so we call it carbonic acid. Next at the top, we'll actually finish 19. We have ClO minus, which is a hypochlorite. It's hypo with the ite ending, so it's hypochlor us acid. Remember that polyatomic is hypochlorite. Next is a sulfate ion, which is sulfuric acid. That makes this guy sulfurous. Again, watch the ending to your phosphorus and your sulfur-containing acids. This one, phosphoric, because it ends in an ate. All right, let's write out some formulas. Hydrosulfuric acid is a binary, H2S. Nitric has nitrate in it, so HNO3. Hydrocyanic, it follows binary rules even though it's not a binary acid because it ends in IDE, so that's HCN. We just use the cyanide prefix. Periodic acid is the periodate ion, so it's HIO4. Acetic acid, you will know this by the end of the year in your sleep. Hydrobromic is binary. Phosphorus, us means phosphite. And then oxalic, I don't know if you remember that polyatomic, it's on the list, it's just not a very common one. It's H2C2O4. Do your homework, practice, practice, practice. If you need more practice than the few on the homework, go do the textbook problems in the back of the book. They have the answers to the odd problems in the index of the textbook. See y'all later.